All right. So let's talk about how to do carbon monoxide. Okay. So we've got our carbon, we've got our oxygen. We know that our carbon has 4 electrons around it. And we know that our oxygen has 6. Okay. There's my 6 for my oxygen. So here is one of those single bonds. You can see that coming together, I think, pretty well. If I take an electron from here and here and bring it into the center, I've got another bond. So I'm going to take those away and I put them right here. Now, I need to keep my electrons paired, and I need to get 8 on each thing. So if I slide these 2 electrons up to here, I'm going to have 8 electrons around this. And then if I slide this electron up to here, I will have it paired. And at that point, my carbon will have 8, and my oxygen is going to have 8. And let's go back and double check our totals. We had 6 and 4 here, which is a total of 10 electrons. 2, 4, 6, 8, 10. So we're good there. Does that make sense?
Yeah. But where does the number 8 come from? For they both need 8.
So everything needs, except for hydrogen, everything needs a complete 8 to be like stable. Okay. You might want to go back and watch my video that I did on Tuesday when I introduced Lewis dot structures.
All right.
That is posted on Google Classroom for Tuesday, January 18th. So I try to post every day a video showing what you miss. So if you are gone and you have time and you feel like it, I'm not saying that it's an absolute, but you probably want to try, if you can, to watch the videos before you come back so that you're not getting in here and going, I have no idea what she's talking about. Okay. But go back to here. This is where I talked about how everything needs a complete octet, how these guys need to be in pairs when they are on here, and that sort of thing. Okay? That makes sense? All right. Any other questions from the homework last night? I did include the answer key online, so you should have been able to consult that last night after you got done with the assignment. Do you need me to put those answers up? Huh? 7? Okay, let me see what 7 looked like. Page down. 103 minus, okay? So on here, I've got my nitrogen. My nitrogen has 5 electrons. So I'm going to put my 5 electrons around there. Let me get rid of this guy. If he will let me slide him out of the way. There we go. And then I'm going to draw my oxygens around here. So remember the formula was NO3 minus. This minus means that I'm going to have an extra electron. So we'll come and grab him in just a second. I've got my oxygen. I've got one of my oxygens coming in right here. So there is a bond between those 2. I have another oxygen coming in here. So there's the bond between those 2. And then I have another oxygen coming in here. And again, there's that bond. Now, remember I said that I had an extra electron. There's my extra electron. I'm going to put that extra electron, and it doesn't matter which one you put it on. I'm going to put it right here. Okay? So there's the extra electron coming in from right here. So at that point, this oxygen is satisfied with 8. Each line equals 2 electrons, so 2, 4, 6, 8. Now I still need to monkey with these guys. If I take this here, this, and move it into the center, then that will give me a double bond, and it will take care of this oxygen. And then my nitrogen, I can't bring this guy up here, okay? That wouldn't take care of the oxygen. I can't bring this one down here and make this a double bond. The reason is that nitrogen then would have 2, 4, 6, 8, 10, and I can't do that. I can only have 8. But what I can do with this electron is I can redistribute it. I can move it over to here. And at that point, then, I have the correct number of electrons. So this was 5. This was 6 times 3, which is 18. And then I had 1 here. So I had 23, 24 electrons that I needed to place. So we're going to go through and count up our electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I'm good with my number of electrons. Now I'm going to check on those octets. I'm going to check to make sure that everything has 8. So this oxygen, 2, 4, 6, 8. This oxygen, 2, 4, 6, 8. And this oxygen, 2, 4, 6, 8. My nitrogen, 2, 4, 6, 8. Now, the last thing that I need to do for this is I need to put it in square brackets so that I can put that charge out here. So let me get rid of some of this stuff so that it doesn't muck up the works. And then I'm going to put my negative sign here. That indicates that this is a negative ion. So we've added 1 electron here. Did that help with 7? What else would you like me to go through? I'll go through as many as you guys need me to. I'll go through the whole sheet if you want.
Do you go through number 8?
Sure. Sure, just a second. Let me see what 8 is. C2H, is that H6? I gotta look at it.
Yeah.
6? Okay. C6, C2H60. 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 All right. So, are you done? Okay. All right. Done. Yeah, all right. So my carbons are going to go in the center. I'm going to have 4 electrons there. I'm going to attach another carbon to it. They have 4 electrons. 4 times 2 is 8. Now I'm going to go through and I'm going to place my hydrogens. So I'm going to put a hydrogen here. Remember, hydrogen's happy with 2 electrons. Put another one here. Another one here. Another one here. Another one here. Now, if I place that final hydrogen, don't do this. If I place that final hydrogen here, what's the problem? I don't have any room to put my oxygen, so I can't put that final hydrogen there. What I need to do is I need to place my oxygen here. So I'm going to put my oxygen here with its 6 electrons. And then I'm going to attach the final hydrogen over here. Does that make sense? All right, what else do you want? All right, I am going to start in then talking to you about what's called VSEPR structures. So that is the next section of your packet. All right, so VSEPR is used to describe the shape of the geometric shape of our molecules. Oh, I got to turn on comments here, then it'll let me write. All right, there we go. So this is going to display the geometric shape of the molecules. Single, double, or triple bonds all act as one when we're talking about the shape. So that's if you have a double bond, a triple bond, a single bond, it's not going to change the shape. Okay? Your unbonded electrons, we call those lone pairs. And I'll show you what I mean by that in just a second. And then your electron density of your lone pairs and your bonds will, they're going to arrange themselves evenly around an atom to minimize the repulsive forces. Remember, your electrons are pushing away from each other. They're the same charge. They're the same charge, and so they're going to push away from each other when they're near. Okay, it's like magnets. You get two magnets that are the same poles together, and they're going to push away. They're going to repel. You felt that before, probably. All right. So in order to determine your geometry, you're going to draw the Lewis structure like we've been practicing for the past couple of days. You're going to count how many bonds are around the central atom, and then also look for lone pairs. And that will determine your shape. So the shapes that we're going to cover in here are the following. Okay. The first one is called linear. So an example of this would be when we did our carbon monoxide today. This would be linear. Okay. They're going to be pushing away from each other. They're going to be in the same plane with one another. Actually, that's probably not the best one to show. What's a better one than that? That doesn't have lone pairs. Yeah, I don't want to use that one. Don't use that one. Linear. Oh, I know. Carbon dioxide. That's a better one. Okay. And we're looking, when we look at these, we are looking at the central atom to see how many things are attached to the central atom. So the central atom here is carbon. When we have this guy, we have two atoms bonded to it, and we don't have any lone pairs of electrons on the carbon. So that gives us a linear shape. And what that looks like is this. Okay. So when you are looking at these, it's going to be straight across. So your bond angle here is going to be what? You have a straight line. What is your angle there? Huh? 180, right? So your bond angle there is 180. All right. The next one is bent. And what bent is would be like water. Okay. So here you've got two lone pairs of electrons. and you have hydrogen attached to it. So that's an example of bent. You're going to have two things bonded. You've got your two hydrogens bonded, and you have your two lone pairs. And so your bond angle there is going to be 104.5. And I have that down below on this drawing. Okay. So that's the example right here. That's your bent. That's 104.5. All right. This is what that looks like. Where did that guy go? Here it is. Okay. So my lone pairs have more of an influence than my two atoms. So this would be like my hydrogens here. And this would be like the lone pairs of electrons on the oxygen. Okay. And that's why, even though you see it drawn, here, you're like, how do you get 104.5? Well, remember, we're drawing this in a two-dimensional space, but this is actually a three-dimensional object that we're working with. Okay. So this is what that looks like. That's your bent. The next one is trigonal planar. This is where you have three things bonded and 0 lone pairs. So this is what that looks like. This is our trigonal planar. And you can see it's all in one plane. That's why they get that name. That makes sense? See how it's all in one plane this way? All right. Trigonal pyramidal, then, you're going to have 3 bonds and 1 lone pair. So that looks like this guy. Okay. So your bond angle here is going to be 107.5. And that's what he's going to look like. And then the last one is called tetrahedral. And that's what he looks like. Now, tetrahedral, when you see that drawn on paper, you see it drawn like this. So your gut instinct is that the angles between here is what? What would your instinct be for your angles here between these? 90, right? That makes sense? But remember, you're trying to draw something in 2 dimensions that actually exists in 3. So when you have it in 3 dimensions, you can see that that's going to push these other ones away, and it's not really going to be 90. You have to kind of override that feeling in your brain and go, yeah, this is not 90. This is actually 109.5. Okay? Now, we don't expect you to memorize those or the names or anything. But if you get into AP, we actually have these plus a few more that I teach you in there as well. Okay, so if you go off to college and take chemistry, you may have some other shapes in there that you cover. Okay? So what we want you to be able to do at this level is be able to draw these, be able to identify how many atoms are bonded on and how many lone pairs you have, what that geometry is, and then what its bond angle. So let's draw this guy. We've got our carbon here. I have my chlorine attached here. What you need, hon? Yeah, sign out on the board. And then take a pass with you, please. My fluorine here and a fluorine here. Okay, so get that drawn, and then we'll analyze what's going on with it. All right. How many atoms do I have bonded to the central atom? How many things are bonded to your central? 4. Do I have any lone pairs of electrons on my central atom? No. So this is 4, 0. So we're going to go back up to our chart here. Oh, I never filled it out on here. 4 and 0. So this is tetrahedral. So that is the name of this. And then we look down here at our chart to see what that angle is. That's 109.5. So we're going to go tetrahedral. And 109.5 degrees. All right. Here's what the next one looks like. So you can draw that one in. Right. And we're talking about the central atom here. So see if you can fill out these two and figure out what its geometry is from the chart and its angle. All right. So you should have seen that there were 2 atoms bonded to the center and that we have 2 lone pairs of electrons. So if we go back up to our chart here, we're going to look for 2, 2. We have 2, 2 here. That's bent. And bent angle is 104.5. Yes, sir.
What are the lone pairs?
I have a lone pair here and a lone pair. Oh, why did that do that? That's weird. Let me highlight the other one, but it wouldn't let me highlight that. There's the other ones. Okay. So those are the lone pairs of electrons. Remember, it's on the central atom. We don't care about these guys. We're only looking at the central one. Yes? Good? All right, let's look at the next one. Let me draw that in for you. So this one, you're going to have your hydrogen. You're going to have your carbon. And it's going to be triple bonded to this nitrogen. Okay? So, how many atoms are bonded onto my central atom? How many do I have bonded onto my central atom? 2. Does my central atom have any lone pairs of electrons? No. So look back at your chart. What is this guy called? Linear. And his bond angle is 180 degrees. All right. Next one is SiBr4. Let's see if you can identify that one. All right, what's that guy called? What do we call him? Tetrahedral, good. Remember, tetra means 4. We talked about that when we were doing covalent naming. So tetra, or if you've ever played Tetris, tetra means 4. And then its bond angle is going to be 109.5 degrees. So 4 and 0. All right, next one, we have our nitrogen. And then we have our hydrogens coming over here. Let's see if you can figure out these next 2 boxes. So you ate that or? All right, so you should have found that we had 3 atoms attached. And then here are our lone pairs for this guy right here. So we've got 1 lone pair there. So that makes this trigonal pyramidal. And it's 107.5. And you can kind of see where they get that name from if you look at this. Okay. Here's your trigonal, your 3. And then it looks, you can kind of almost visualize a pyramid in a way. So that's where they're getting that name from. All right, so then turn this here. I can't do it with that. Rotate clockwise, clockwise, clockwise. There we go. Now we can see. All right, so let's do a few more of these. So we can get this a little bit bigger for you. So practicing some of our formulas again. Hydro, when we have hydro and we're dealing with an acid, remember the hydro, there is no oxygen in that formula. So hydro, there is no O. Okay, so no oxygen should appear in that formula. We always start acids with H. And in this case, our anion is going to be sulfur. And then you need to look up the oxidation numbers. This is a +1 and a -2. So you need 2 +1s to balance this out. So if I have 2 +1s, that'll balance out this -2. So that's the formula for that guy. And then if we draw this, this is what that looks like. So how many atoms do I have bonded to my central atom? 2. How many lone pairs do I have on that guy? 2. How many total number of electrons do I have? 2, 4, 6, 8. And then my bond angle here is going to be what? Well, we need to go back up to our chart. What shape is this guy? Let's skip over to that first. Let's look again at our chart here. Oh, it didn't save for me. Okay. Why is this not moving the way I want? Yep, it's bent. Good. There we go. I'm getting it back now. There we go. So it's going to be bent. And its bond angle is going to be 104.5. So if we were to look at that, this is what that looks like, okay? Here are your two hydrogens, right here, and here are your two lone pairs of electrons. That make sense? Hydrogens, lone pairs of electrons. You see why it's not going to be linear here? It's not going to be straight across. That would look like this. We've got four things at play here, so you've got to take that into account with your geometries. Okay, and your lone pairs actually have a greater influence than the atoms that are attached because they are directly on that central atom. They're not a different atom. They're not a different element. They're sticking right on there, so they're going to have a bigger influence on it and push it down a little more. All right, nitrogen trihydride is going to look like this guy. Oops, sorry. Oh, I got that in the wrong spot. All right, let's try that again. So this is going to be N. So that's my nitrogen. And then hydride means hydrogen. So that's my 3. So my nitrogen is going to be here. And I'm going to have my 3 hydrogens drawn outside. Let's see if you can answer the questions on that guy.
Proper dial 5251, Kevin Proper dial 5251.
All right. On this guy, you have 3 atoms. 3 atoms here. You have 1 lone pair. And we have a total of how many electrons? Well, this guy has 5. This has 3. So that's a total of 8 again. And our angle this time is going to be 107.5. And we call that trigonal pyramidal. All right, the next one is carbon dioxide. So carbon comes first. How many oxygens do I have? 2. Di means 2. So when I draw that in place, this is what that's going to look like. So how many bonded to the central atom? 2. Does the central atom have any lone pairs? Okay, total number of electrons, well, I have 4 here, and I have 12 here. So that is a total of 16. This guy is going to be linear, and his bond angle will be 180. The next one is sulfur trichloride. So chlorine, we're going to have 3 of those. This is what its structure will end up looking like. So see if you can figure out what belongs on the rest of this. Oh, yeah. It may not be the best one for you guys to do. Now, just draw it like that for now. I'll not worry about that one. I won't get into all of that nastiness with you guys. Just see what you can come up with this information. You should see that that is 107.9, and this is Trigonal Pyramidal. All right, carbon tetrachloride. So carbon is here, chlorine, or hydrogen, sorry. I don't understand why everything goes away when I do that. It should just be this little bit's here. Taking a whole bunch of stuff from up above away. Try to make that into an H. So you're going to have your carbon here, and you're going to have your 4 hydrogens around it. So this will be a 4 and a 0. And this will be 8. And this will end up being tetrahedral. And then the last one is phosphorus tetrachloride. I've got my phosphorus and my chlorines going around it. And I have a lone pair of electrons here. So I have 3 and 1. Here I have 5 and 21. It's 26. So this ends up being 107.5. And this is Trigonal Pyramidal. All right. So tonight you have, you've just got, it looks like 5 or 6 problems here on 8-4. Looks like 6. Let's see if you can do those 6 problems tonight for me for homework, okay? Not a lot? Is it okay? Handle that?
Why would you?